Okay, I just want to say thanks to everyone for taking some time out of your busy day for our webinar that we're hosting today. Again, my name is Tom Wood. I'm the Program Manager for Vertical Rescue Solutions by PMI. I handle a lot of the educational training and consulting duties for PMI. What we'll do today is we'll talk about some kind of a general overview of industrial on-site tower rescue versus professional tower rescue. There is a difference, and we'll discuss some of those. I won't be able to go into great detail or great length. Obviously, it's a very broad topic here, but what we're going to do is just try and touch on some main objectives that we want to discuss, and then see where that takes us. That may not take us anywhere if this thing doesn't advance. There we go. Okay, what is so dangerous about tower rescue? And I'm speaking here specifically about telecom towers. Obviously, there are different kinds of towers, high voltage towers. You can even consider wind turbines towers as well. But what we're looking at right here today is specifically telecom towers. Okay, obviously there's a lot of things to be concerned about doing work on these things. Obviously extreme height. I'm not sure what the record is for the tallest freestanding tower is in the United States now, but I'm guessing it's closer to around 1,1700, maybe even more. That's quite a bit. I don't think most of us carry around ropes that long in our rigs with us or on the job site, so something to think about. Microwave and radio frequency radiation exposure. There's a reason why there's towers there. It's to put these antennas up there. And typically you're going to have microwave RF antennas in a whole different ranges of frequencies. So one tower could have anywhere up to 75 or 100 antennas on it, believe it or not. Some may have as little as 1 or 2 based on where they're at. Obviously high winds, you're not on the ground anymore. That's a big concern. If anyone has ever had to be up on a tower and when it's windy, it's a whole different experience climbing versus when it's a nice calm day. High voltage, another concern. Not just high voltage concerns from the wires running up inside of the tower itself. There may be high voltage lines running near the outside of the tower that are not related to that tower. Ropes can be entangled in them, all kinds of concerns along that line. Also, if you ever have the displeasure, I guess, of working with AM radio towers, you know that each one of those towers is set up with a detuner. Basically what happens with AM towers is they become electrified through the types of radio frequencies that they emit. And this electrifies the towers themselves. They have to be grounded. There's a lot more science behind it than that, but that's the best you'll get out of me. Also, a lot of these towers, they're in remote locations. You see the picture here. It doesn't look like it's a very remote location, but typically when you get further out west, you'll find towers for the most part in the middle of nowhere. There's not going to be a cross street that you can reference if you were a responder having to go to a rescue at a location like that. So again, the locations themselves make for some of the difficulties that tower rescuers must face. Okay, there's a reason why we've got so many towers now, and I'm sure as everyone here has noticed, there's more every day. This is due in large part to our increased usage of cell phones and also the needed wider bandwidths than what we had in the past. Everybody hates those dead zones. As much as everyone hates to see these towers go up everywhere, some people hate even more the fact that they can't talk on their phones wherever they go. So again, that's going to lead to more towers. It's estimated that 250,000 more towers, in addition to the 190,000 we have now, and again, these are only telecom towers, are going to be needed in the next 5 years just to keep up with the demand. When you think about it, it's taken about 30 years for those 190,000 towers to go up, and look how, in 5 years, they're basically talking about 250,000 more. So we've got a lot more guys up in the air, a lot more towers being built. Okay, it's a dangerous job. There's not as many tower workers as there are probably loggers or postal workers. But the few of them that there are out there, they have a pretty tough job. You know, they deal not just with maintaining these towers and antennas, but also building them as well, which is a whole different ball of wax when you're looking at objective dangers as well, because then you have cranes becoming involved. So again, it's a pretty dangerous job. You know, back in the day, and this is all you needed to be a tower worker. They had a pretty cowboy attitude about a lot of the work that was done. Basically, you know, your rescue and safety plan was don't fall. And look where that led them. These numbers reflected just basically the reports for OSHA that they filled out. You'll see that's quite a few people. It's gone down in the last couple years, and that's due, I think, in large part to organizations like the National Association of Tower Erectors that are really pushing safety to the forefront of the tower industry. But you know, this is actually a very small number compared to the actual number of fatalities, because those numbers do not take into account self-employed tower workers, or if they're a sole proprietor of their own business. They don't take into account illegal aliens doing tower work. For tower painting, this is especially a big problem. Ham radio tower climbers. Every year, a handful of tower climbers in their backyard, basically, ham radio operators, fall. And they aren't considered part of those numbers. So obviously suicides, that's something different. Those aren't tower workers. And then when you throw into the mix base jumpers, people who get drunk climb towers, and I'm sure there's some listening here today who have interesting stories about rescues along those lines. And any other person who sees a tower and thinks it would be a great idea to climb with no thought given to how they're going to climb down or what happens if they get hurt up there. Okay, industry's response. No more Daisy Dukes. PPE is a big part of the safety push that the tower industry has been promoting. 100% tie-offs for workers all the time, and that may seem like a no-brainer for us who don't do tower work every day, but having done a very tiny bit of it myself, I can just tell you that it's a lot of work staying tied off all the time, crawling around with tools on you, up through steel members, up and over things. It's a very conscious effort you have to make, and unfortunately a lot of folks try to shortcut, take a quicker way to get their job done, and sometimes they pay the price for that. There's a lot more requirements these days for tower workers to get rescue training, to get fall protection training, PPE inspection training. That's been a big push by NATE as well. There's a bigger emphasis these days on using the correct gear for the correct job. You know, it's really frowned upon towing your truck out of the mud and then using that same rope to go climb the tower with. You know, there's a big difference between life safety gear and work used for lifting that's not man-rated. Anyone who's done any kind of crane work can tell you those differences. There's a big difference, and everything may look like it's rated for a huge load, but testing is different on different products used for life safety. Also within the tower industry, they recognized that there was a problem, and they decided to start policing their own people, pushing safety a lot more to the forefront, not making it something that was done begrudgingly, but rather willingly. And along those lines, they formed a lot of OSHA compliance partnerships with the various tower companies throughout the country, and that's resulted in significantly fewer accidents and fatalities. Okay, the government also had something to say about stepping up safety. OSHA has a vested interest in making sure that people are kept safe. What they've done is basically in the past, it was permissible for a tower company or a tower climber to say that their rescue plan was to call 911. The government has stepped in and said, you can still do that and you should still do that, but ultimately the responsibility for your safety and for your workers' safety is your own. So what they've done along those lines is require that there has to be rescue equipment on site with these guys. They have to be wearing the proper gear. They have to be trained in rescue. And they have to have all that documented. You can't just do a tailgate safety meeting every morning and say, we talked about not falling today, and have that be adequate, at least not in OSHA's eyes. They've upped some of the requirements for the strength of personal gear used, and a great example for that is carabiners, and I'll go into that here shortly. And lastly, many of these companies are very large companies that erect towers, and some of the fines, quite frankly, that were levied even for willful negligence that resulted in death were laughable, a few $1,000s. What OSHA has done to mimic what has been going on in Europe for quite a while is they've made, they put some bite into the monetary fines that they levy. Also, they have added the threat of jail time if there is something that a willfully negligent act that results in fatality. So again, OSHA is really stepping up its game. As a result, as you saw that one year, 2006, there were 18 fatalities, and again, that would probably be about a quarter of all the deaths of people who fell off of towers that year, if you counted the other factors. Okay, the result, obviously, everyone's tied in all the time, and so what happens when they fall? Well, more often than not, you never hear about what happens after they fall because they're able to figure it out themselves, get off of their lanyards, get back onto the tower, and self-rescue. That's part of the deal for those guys. They work with lanyards all the time. They're attached to their dorsal attachment point on their full body harness typically when they take a fall. As long as they're not falling a great distance, it hurts, but typically on a tower like this, they can go ahead and get back onto the steel. But that being said, if they do take a fall and injure themselves in any way, or they are sickened by radio frequency exposure, which basically mimics instant flu-like symptoms that weakens you to the point that you can't pull yourself back up, that's when they need rescues. Okay, here's an example here. 2002 in Nebraska, tower worker was injured at the 1,200-foot level of a tower while installing a cable. By the time his lifeless body reached the ground, the National Guard had become part of the rescue effort, and nearly 12 hours had elapsed since the initial 911 call was made by his coworkers. Back in those days, there was no on-site rescue plan required, so they did not have one. Or at least if they did, it was not an adequate one to rescue that man. Professional rescuers were hampered by the fact that the tower had no pre-installed safety climb system. So all rescuers had to climb the ladders using their scaffold hooks, which is a laborious process if you've ever had to do that for 1,200 feet. Further complicating the rescue was the fact that the longest rope that they could get a hold of and get it on the site was 400 feet long, obviously necessitating multiple anchors. The injuries the subject sustained were head injuries. It's debatable on at what point he expired, but needless to say, 12 hours for doing a rescue. If he hadn't died from the injuries, more than likely by that time he would have died from suspension intolerance or orthostatic intolerance, depending on what you like to call that. Okay, when you're a tower worker, you're not really held to the same rules as a professional rescuer. You are a tower worker. You are required to be able to perform rescue, but you do not have to purchase gear or meet the training requirements that a professional rescuer would. So along those lines, ANSI, Z359 2007, addresses a lot of those issues as far as what equipment is appropriate, what training is appropriate, and what should be done as far as rescue training for tower workers. And then not just tower workers specifically, but anyone who works at height. Again, the construction phase for towers falls under the A10 standard for OSHA, so that is a little different. But again, if you look at general consensus standards that are referenced most often, you'll probably see ANSI for work at height on towers. Being a professional rescuer, you're held to a different set of rules. I think that's a good thing. The National Fire Protection Agency, Association, NFPA, creates a lot of those standards. Not just with rescue or gear, but everything from fire suppression to building inspection, things along those lines. The difference that you might see here is that, even gear that should be meeting a certain weight requirement or standard through NFPA, there's no one who wears an NFPA badge and walks around and arrests people for not using gear that's not marked NFPA. Whereas if you look at ANSI, some of the rules that they have written and standards that they've come up with are referenced by OSHA, and they do act as police along those lines, and they will enforce the rules written. Whereas with NFPA, even though OSHA does occasionally reference it, depending on the situation and what state you're in, NFPA typically is not involved with OSHA. Okay. You need to know what you're dealing with when you're a rescuer coming up on scene for a tower rescue. Tower workers, will be using different tools than what you might be accustomed to if you don't do that kind of work all of the time. One of the first things that you'll notice is that they wear hard hats. They don't wear helmets. They're not required to wear something with chin straps. Though many of them have little bungee type chin straps that can fasten onto their helmets, or I'm sorry, their hard hats. Typically they're wearing hard hats. So every time the wind blows, they lean over, or God forbid they take a fall, that hard hat is just going to go flying. So that's just a little personal soapbox of mine there. But you'll also see that they have twin climbing lanyards typically, usually with a built-in shock absorber, so that if they do take a fall, they can keep that impact force at a minimum on their bodies. They will typically have work positioning lanyards, which are different than their fall arrest lanyards or their twin climbing lanyards, in that they're only supposed to be used to get themselves where they need to be and hold themselves in place. They should not ever be a sole attachment point for fall arrest. Typically on more towers now than not, you'll find that they have an installed safety climb system, which is a 3/8 inch cable, which is anchored at the bottom and the top with a shock absorber typically on it, right up the middle of the vertical ladder that you can use to access the tower. So again, it's a little carriage that as they go up, it captures their progress, and if they were to lean backward or fall, it would catch their fall. That way they do not have to use the climbing lanyards to access the tower. Usually, but not always, they will have an RF monitor with them, which measures that radio frequency exposure. It will let them know when they exceed the maximum permissible levels of exposure, as deemed by, I believe, OSHA. These are warning devices only. Typically, when tower workers are up on a tower doing work, they will have communications with someone in the shack down below, and they can power down antennas as they climb past them and then power them back up once they're out of range. So an RF monitor is a very important investment for these guys, because occasionally, even when they try to do their lockout, tagout procedures, inevitably once or twice a year you'll hear of someone getting fried by one of these antennas, especially the very powerful digital antennas, because someone came in down below and powered everything back up before they were ready. Also, you'll see that they have ANSI-rated steel carabiners. I mentioned this earlier. The difference in these carabiners in comparison to the pre-2007 ANSI update was that in the past, the gate strength, not just for carabiners, but for all connectors used in industry, was around 350 pounds. So basically, if you pulled from the outside across the middle of the gate on a carabiner, it only had to withstand 350 pounds of force. That has changed now. That is now, I believe, 3,600 pounds of force. They had several fatalities, and they had some late last year and even one this year, where someone was using older style gear, connectors, specifically, that when they took a fall, it rolled out or it was loaded across the gate and failed. Okay, tower rescuers, or rather tower workers, once they have to become tower rescuers, once one of their companion workers needs a rescue, there's a set of rules that dictate what equipment they should be using for that as well. Specifically, ANSI wants to see, and I believe this is the .4 standard of the 2007, is that they want to see auto-locking descenders that stop when the rescuer lets go, or if they squeeze too hard, they also stop. They want them to be rated for at least a 2-person load. They want to see, obviously, the ANSI-rated carabiners with increased gate strength used in all of these. Anchor straps that are used to anchor to the steel up above where the rescue has to take place should meet the ASTM or ANSI standard at 5,000 pounds. It's up to whoever is putting the kit together to decide if they want to use 1/2 inch or 7/16 kern mantle rope, or occasionally they will use 1/2 inch or 5/8 braided or laid rope as well for these. Obviously still life safety rated. What's recommended most is that these rescue kits or rescue solutions, whatever you like to call them, are pre-rigged, on-site, and not used for everyday work, because inevitably someone will borrow a beaner from here because they're in a pinch, you know, or you know, a pulley from there, and it's time to do a rescue, and guess what? You don't have the stuff in the bag you need. So again, you may see that some guys will take the rescue kit up to the tower with them every time. Most don't. They just leave them in the tower truck, their work truck, and will retrieve them if they need to in the event of a rescue. Professional rescuers, on the other hand, they have a different set of things to consider when they're approaching a tower rescue, or any rescue for that matter. Much of their gear needs to be adaptable. Obviously, some of it is very specialized, especially when you get into confined space. But for most typical rope rescues, they need to have a whole lot of arrows in that quiver. And some of them may work for towers, and some may not. Okay, some of the things that you'll see used, again, if you're a tower worker and you're not familiar with what a professional rope rescuer might be using to rescue you, they will use prussics, whereas most guys in tower work prefer mechanical rope grabs for the most part. Obviously, prussics are loops that capture your progress on a rope. Different set of rules for carabiners. You know, they want that 8,031 pounds, I believe, G rating is, which again is different than the ANSI one. Brake racks will be used quite frequently, and maybe auto-locking descenders. It's dependent on what their department uses. Obviously, the big issue when you're using auto-locking descenders is to have a compatible rope diameter with the device you're using. Very commonly, mechanical advantage systems will be used, and this is typically put into place to lift someone off of their lanyards after they're hanging there. Cutting is a very last resort, and I can't stress that enough. It's an option, and it should be a last choice, never a first choice, to cut someone away from their gear. There's just too many mistakes that can be made. So mechanical advantage systems can be used to get that person lifted up off of their lanyards and onto your system. They may or may not have factory-made climbing lanyards. They may have cow's tails with prussics on them for positioning lanyards. Again, they have to adapt their tools to a variety of different situations. Most of the time you'll see them wearing a full body harness, but it may be possible, depending on who receives the call and what they're geared for, they may be wearing a seat harness and have a separate chest harness, maybe a homemade one, added on. They will have litters. Typically, it's pretty hard to load someone into a litter hanging off a tower. The best way that most people will get the medical care that they need, other than perhaps putting on a cervical collar up on the tower, would be to get them down quickly. Hanging for a long time puts quite a beating on a person's body, and typically the quicker you can get them down, the better off they're going to be. And as we all know, you can't effectively do chest compressions on someone hanging in midair. These guys will have helmets with chin straps, and they will be using either 1/2 inch or 7/16 or 11 millimeter kern mantle rope. As I said, I don't think most rescue professionals use later braided rope anymore. Okay, tower rescue on site. You're going to have 1 to 3 guys. They don't send out a whole lot of workers to do each job. They're trying to get away from single lone workers for obvious reasons, but there may only be 1 other person on site to effectively do this rescue. When erection of a tower goes on, obviously they have cranes, lifts, man buckets, all kinds of things available, and if it's at all prudent or possible, they will use these. But typically, it's going to be hard-pressed. You're going to be hard-pressed to find a crane or anything like that that will get you over 200 feet unless you're riding the ball, and that's a scary proposition. One of the biggest differences that you'll find between on-site tower rescue versus professional rescue is these guys will typically be using a single rope technique, almost more similar to what cave rescuers or mountain rescuers might be thinking about. Okay, various types, obviously, and there's a million different ways to skin this cat, but I'll just touch on a few of the really basics. Whatever pre-rigged system that these guys have on site that they're using should be able to do more than just one kind of rescue. That's the goal. One of the better options will be lowering the rescuer to the subject, attaching them, and then sending them both down. Or if you're lucky enough to be able to access the person with the carabiner and get them clipped in effectively, you can just lower the rope to them and then lower them down, depending on the situation. Companion rescue by controlled descent. You'll notice that the word rappel does not come into this situation. In industry, rappel is a dirty word. They prefer controlled descent for obvious reasons of what it entails. Again, this is fixing an anchor up above with a 5,000-pound rating at least, we would hope. Dropping down to the subject and then hopefully unweighting them off of their system using maybe a set of 4s or an inline mechanical advantage system based on the rescue system that they have to get them off of those lanyards without cutting them, and then continuing to the ground. One of the benefits of doing this is you can control the subject as they're going down. You can keep them off of the steel. And this is definitely a situation where you want to go down the inside of the tower if at all possible, especially if it is a self-support tower, which has a slight angle on the outside steel, which you would have to keep bouncing off of on the way down. Going down the inside, as long as it's more or less free of obstructions, is typically preferable when you're doing an on-site industrial rescue. Sometimes the best way to get someone up is to just simply raise them. This may involve just finding a way to get a hold of their lanyards and lifting them back up to where they fell from, or it may involve setting up a 3-to-1 or a 2-to-1. It's hard to say. Whatever way works best to get them up. Typically, though, you're going to find that someone who is raised in this fashion up to a platform is not injured, because otherwise you still have to find a way to get them down once you have them back up there. Okay, professional tower rescue. Some of the things that you're going to see here, one of the biggest differences is you're going to find that they typically try to stay out of the inside of the tower and work on the outside of the tower. And usually they'll try to control the loads from the ground. This gives them a little bit more leeway as far as personnel that are available and exposing fewer rescuers to the hazards up on the tower. Obviously, they've got to deal with lockout, tagout issues before they climb the tower, and hopefully a site technician will be there, or at least someone who is with the tower crew who knows how to power the antennas down. There is not one big switch that powers everything down. Typically, these antennas are owned by several different companies, several different people, including the government, and then often they have their own ways of getting them shut down. So it can be quite a complicated process to do that if you're not familiar with it. Again, if they are doing the rescue from the ground, that involves more rope. Obviously, they're not just anchoring from a point up above and going straight down. So, for instance, if the subject is 300 feet up, they may require more than 600 feet of rope, depending on what system they're using to get the person down. Another big difference versus on-site rescue is you'll find that typically professional rescues are going to use a 2-rope system, which is a main and belay line. The main line is typically weighted. That's got the full weight of the person on there. And the belay line, though kept tight, is typically independent, run through independent anchor points and with a separate brake as well. And again, the desire is typically to get the person from the outside of the tower down to an ambulance or the truck that's usually serving as an anchor. So a lot of times what you'll see is they will come down on the outside of the tower with a separate line and what I call skate them on a separate line independent of those 2 lines down to where they need to go. Okay, rescue for tower workers, again, it's something they're responsible to do, but it's not their job. It's not the thing that they think about every day. They're focused on getting the job done. They have a different job. As of the ANSI standard in 2007, they are responsible for their own rescue on site. But again, unless an employer cares enough about their employees to offer, or not even offer, I would say mandate, rescue refresher training at least every 6 months, these guys are going to forget these rescues. And again, these pre-rig systems should be set up where they shouldn't be tying knots. They shouldn't be thinking, well, does this slot go into this hole? How does this work? It should be a clip and go type situation. Even that, if it's not been practiced within the last 6 months, is going to be difficult for these guys to take into consideration, given the fact that they've just witnessed their buddy hanging there or been injured, and they've got that added stress. They're not rescue professionals. They're not trained to psychologically deal with the possibility of a rescue. They're just not, that's not part of their job description. So again, if they're not practicing those skills, they're going to become rusty. On the flip side of that, tower rescue for rescue professionals doesn't happen very often. It's a very difficult event to train for, in that you can spend a lot of money on training and gear and never use it. The likelihood of you using it is going up, it's not going down. But again, it's expensive, and it's a lot of time to train for these things, especially given all of the other things that rescue professionals need to become proficient in. Confined space, swift water, vehicle extrication. There's a lot on their plate. And frankly, tower rescues don't happen very often. They happen often enough where, you know, people need to be concerned from a fatality and accident standpoint, but it's something that's a very tall order, very funny joke, to train for. Ultimately, the responsibility for rescue falls with the employer. They are the people exposing people to work at height. They are the ones who are responsible for making sure that they are kept safe and they are trained, and in the event that someone falls, that a prompt on-site rescue is available. I believe that the general rule of thumb that they like to throw out there is contact needs to be made within that, for that subject within 6 minutes. So they need, you know, whoever is on site within 6 minutes of an accident should have a pretty good game plan about what they need to do to get this person rescued at that point. If someone's really on the ball and they really get things going quickly and they've practiced their rescue techniques, it's not unreasonable to think that a person could be rescued within 15 or 20 minutes. Typically it's longer than that, especially if professional rescue has to be called in and it's a remote location. Obviously, you know, like I said, these towers aren't on the street corner all the time. They're out in the middle of nowhere. So that involves sometimes a GPS location or cell phone coordinates. Even when on-site rescue is initiated, whoever is doing the rescue still needs to call 911 before that rescue begins, for two reasons. One, in the event that they become injured during the rescue themselves because they've made a mistake, because they're under a lot of stress, or also if that person is injured that they're trying to rescue, waiting till they get that person to the ground just ate up maybe up to half an hour or an hour of response time that the ambulance crews or the fire rescue crews could be waiting for them once they reach the ground. But again, once 911 is initiated and professional rescue shows up on scene, if the on-site rescuer has done his job and everything goes well, the rescue should be done when professional rescue arrives. That's obviously not always the case. If there are serious injuries, there are medical concerns, obviously, or perhaps objective dangers like high voltage that the on-site rescuer may not be able to address, whereas professional rescuers can get that line shut down. Or it may be the fact that the person who had witnessed the accident is just incapable of doing the rescue. What you'll often see with tower crews is the person with the most experience has the most rescue training, and typically that same person will be the person doing the most risky work. When they fall, get hurt, their rescue is left to the people who have less training than them. So again, that puts a heavier burden on the professional rescuers when they come in and have to assume command. At the end of the day, it's really all about training and being aware. The attitude, especially among tower workers, that it can't happen to me, it needs to go away. Guys that have been around for a long time and never had a serious fall happen to them, they should be very thankful for that and not credit, you know, so much the fact that they're always the safest guy. Sometimes they're just the luckiest guy. But when it comes to training for tower rescue, more often than not, the departments that do successful rescues on towers are departments that have trained with tower companies or tower owners on those towers. The towers don't go anywhere. It's one of the few rescue events where you can pretty well predict where something's going to happen. If you have a tower and someone falls off of it, guess what? That's where you're going to respond to. So It's you can predict the location for the rescue, just not the time. Okay, so at this point, I will turn this back over to Jessica, and she will field any questions that you guys have that you are hopefully typing in there frantically on, and we'll see if we can answer them. Okay, Jessica?
Yep, thanks. Okay. And right now, go ahead and ask any questions that you have in the chat/questions area of your control panel. And looks like we have a couple right now. The first one is, do you use the Petzl ASAP for the 2-person rescue loads? And then as a clarification, they said, I see this device in a few of the pictures, and they haven't been using it because Petzl discourages it. What are your thoughts on that?
From what I know about the ASAP, I believe in a rescue situation, they say if you can't statically load it, that it is permissible to use it with a 2-person load. And again, I don't have the document in front of me. I'm just going from what I remember. I believe that you can use it for rescue for 2-person load, but you cannot use it in a situation where you are climbing with a 2-person load, or there's a potential for a shock load on that device, if I recall correctly.
Okay. The next one is, where and how do I get a copy of ANSI Z359?
If you go to the ANSI website, I believe that you can, I don't believe you can download for free the entire document all at once. To pay for the document in hard copy and have it sent to you is very expensive, along the line, over $500, believe it or not. But I believe that if you find a section that you need to reference, you should be able to download a PDF of it from the ANSI website, if I'm not mistaken.
Okay, we actually have a couple other PMI people on, and Louis had said that you can get one from the American Society of Safety Engineers.
Okay, great.
And the next question is, have you used the wire rope grab for pro rescue?
No. I believe if you're speaking of the safety climbs, Tractel or DBI makes them, they are, as far as I know, only made for 1 person to climb a 3/8" steel cable, and it has to be, even the type of cable has to be compatible with the type of device. I would say 80% of the safety climbs, or safety carriages or cable grabs, whatever you like to call them, work on the same style and type of wire rope. But as far as I know, every one of them is only for a single person's body weight climbing up that ladder, and that's it.
Okay, and he sent a clarification. He said, in lead climbing for the rescuers to access the patient.
In that, for a lead climber to access a patient, absolutely. Absolutely. If you're using a single person's body weight to climb to access the patient lead climbing up, that's most certainly permissible. Absolutely.
Okay. The next one is someone who works in Alberta, Canada, and many of their clients purchase towers where a 5,000-pound anchor is not available. What words of advice do you have regarding small anchor selection on small towers?
Yeah, that's a very tough call because, typically in the language of the way that most of the standards are written, and I know CSA is a little bit different than some of the OSHA standards, but, they want to see that 5,000-pound anchor strength. And again, they want to see that that's a qualified person from the tower erection company or an engineer. They want to see, and no engineer is going to go up and put a spray paint mark on every anchor point that's more than 5,000 pounds. A lot of that comes if you look at the type of tower, find out who the manufacturer is, and often in the documents, the engineering documents that are available, they will give the strengths of a lot of the anchor points. Typically, there's not many pre-engineered anchor points on these towers, as we all know. A lot of them are X braces, and some of them aren't even steel. They're thinner galvanized type metals. So I hate to say it, but it almost comes down to a matter of just trusting that you made a good decision on where you're putting them. What you'll find typically is anchors or cross pieces that are near the legs are going to be strongest, and X's out in space typically are going to be quite a bit weaker. But you know, it's totally dependent on what type of tower it is, how frequent the bracing runs, what type of bracing it is. There is a provision, at least in the ANSI, or I'm sorry, yeah, the ANSI standard. If you are conducting a rescue, they will allow you to use an anchor that is rated at 3,600 pounds, I believe. So they're giving you a little bit of a break with the strength on that. But again, how do you know it's 3,600 pounds? Unless you're going and proof testing these things, it's almost always a judgment call. And that's where, if you're a rescue professional, I would defer to the tower workers who are on scene, who anchor off of these things all the time for the best information on that specific tower.
Okay. If the tower is 1,200 feet with the 3/8-inch cable, does that mean only one person can climb it at a time?
That's a really good question, actually. It depends on the rating of the safety climb system installed. A lot of the times what they'll do is they'll have what they call rest platforms on something that's that tall. They won't run that same cable all the way to the top continuously. There'll be several step-offs, and they'll be independently anchored side by side almost, you know, a few feet away. Again, all the different cable manufacturers have different recommendations for their load. I would never do more than two people per anchor point, but again, that's completely dependent on the type of tower. And there's only a handful of companies that manufacture these, and their specifications are pretty easily accessible on their websites.
Okay. What is your experience using the Quadra, the ID, or the Spider in two-person lower?
In two-person lower, I believe that the Spider is not rated for a two-person load. I would have to. It is? Okay. It is. I'm sorry. It is rated for a two-person load. All of them have the hands-free option where you let go and you should stay still. I believe they all have panic functions as well. If you squeeze too hard, you're supposed to stop. I know with the ID, if it's just the regular Petzl ID, not the rescue version, which is used on a half-inch rope versus 11 millimeter. If you have a two-person load on the ID, if you're in rappel mode, I believe in lowering as well, you're supposed to use a second carabiner beside it, either hooked through your leg loop of your harness or to a separate anchor point near where you're lowering from to lessen the friction. So again, if you're using a two-person load with the ID, you want an extra carabiner for friction. With the Quadra, it's rated for a two-person load as it is. You can add an extra carabiner for friction if you would like, but it's not typically required by the manufacturer. And with the Spider, I believe that a second carabiner helps as well, but I don't know that it's required. I'm sorry, I don't have all the instructions right in front of me, but from the best of my recollections, I think that's how the differences are for all three of them. Okay.
Who should take the initiative for coordination between tower companies and rescue agencies, the tower company or the rescue organization?
It could be either or. Most good tower companies, and by tower erection companies, I mean the guys that are actually putting it up or doing the maintenance on them, most good tower companies will interface with the local rescue agency if they're doing an extended project other than something maybe of changing out a single light bulb at the top. Most really good ones these days will contact that rescue agency, say, hey, we're going to have guys over here working. Would you like to come over and take a look at the tower, or we just want to let you know in case something happens, you know which tower we're on. And I've also seen it where different fire agencies who are stuck with tower farms, which is what we have here in Colorado near here, the local fire department agency that was responding to those towers in the event of an accident. Basically, met with the tower owners and several other agencies that might respond and had a big powwow and some training sessions, which was phenomenally beneficial for everyone. It cuts response time down in the event that there is a rescue, and I think it goes a long way towards helping both guys that do the work on the towers and the rescuers understand what each of them is facing when it comes to a tower rescue. So it's kind of, it's up to whoever wants to take the initiative.
Okay. Do you find many fire department rescuers using 7/16 over the traditional half-inch rope?
Boy, it just goes right down the middle. Obviously, lots of folks still use half-inch rope. Some are moving towards the 11 mil, mostly as a weight issue on the larger towers. Obviously, even if you're trailing a rope, carrying it up behind you, and you get to 800 feet up, that's a lot of rope weight to be pulling below you. So you'll see that guys are trying to, help out with that as much as possible. Again, it almost comes down to more of an issue of what devices you're using for your lowers or your progress captures or your mechanical advantage systems, because as we all know, not all descenders work with half-inch rope and vice versa. And that's where you'll see a lot more folks going to 11 mil based on what kind of devices they're using. And again, it may be a department-wide decision based on how strictly they adhere to NFPA 1983.
Okay. Similar to emergency contact information postings and signage requirements for things like oil wells and tank batteries, is there an industry standard for towers that requires the tower owner and or operator's contact information to be posted at the base of the tower?
According to FCC regulations, there should be. They're supposed to also have limited access to those areas where anyone could be exposed to RF or high voltage. Signage is required. Again, some of these towers that are out for years without really ever getting much of a paint job or many visitors other than people working on the antennas don't get the care taken that they need to, and it's very common to come onto a tower site and not be able to find the information that is supposedly required by the FCC. And again, that's something where if you are a professional rescuer, just going out and checking out the site and then doing a little bit of homework beforehand will get you not only that person's contact information, but may also save you the trouble of having to break out the bolt cutters down the road if you can have access to a key or a Knox box installed on that facility or the gate accessing that facility. So the FCC does require the signage, but again, it's pretty hard to enforce based on how many towers there are out there.
Okay. Could you discuss the sternal connection instead of dorsal for fall professionals? It seems like sternal would be more safe for climbing steel.
There's a lot of debate about that. When using your lanyards or anything like that for fall arrest, and you have a potential of falling for more than 2 feet, it's required that you attach to your dorsal attachment. So, for instance, this is a very interesting situation. If you were climbing up a ladder and using your twin lanyards to climb with, you would typically be attached to your dorsal attachment point, because most lanyards are at least 2 feet long or longer. Most of them are, some of them go up to 6 feet long. So again, if you took a fall from anywhere other than, having them way up at the top of where your arms could reach, you're going to fall more than 2 feet. So according to most standards, unless you're climbing a ladder and have a safety climb attached to your sternal attachment, or something where you can only fall for 2 feet or less, every other situation requires that you use the rear attachment point. And there's a lot of physics involved with this, for the reasoning behind this, based on when people take a fall, how the shock and the load is distributed down along the long axis of their spine, as opposed to where it's in the front there, where they're going to, if they take a fall, probably lose some teeth, have their nose wiped off, and maybe compound a head injury.
Okay. Are there any systems currently used in tower work that would allow the rescue kit to be attached at the bottom of the tower but not carried up, so if it's needed, it can be retrieved?
Oh, absolutely, absolutely. Guys that know that they're going to be doing something dicey, if they're out on putting an antenna out on an arm, out on a boom, and they will be out away from the tower and have a potential to take a fall, or if it's a windy day or an icy day. I have seen guys that will just take the tail of the rope from the rescue kit, bring it up there with them, and anchor it off so that that is available. Depending on the situation, obviously, if it's a high wind day, if you've got ropes just kind of dangling, you want to make sure that they're kept from blowing into high voltage lines or wrapping around the tower, which would prevent someone from being able to use them for a rescue. But that's most definitely an option because, again, a lot of these guys have several tools on their belts that they're weighing them down, and then bolt bags with them and things of that nature. So they've got a lot of tools and gear on them as it is. It's almost unrealistic to expect that someone would carry a 40 or 50-pound rescue kit up every time they go up a tower. But what a lot of guys will do is kind of take a shortcut there and bring part of the rope up with them or part of the system and then haul it up if it's needed. That's a good question.
Okay, that looks like all the questions we have right now. So if you have any last-minute ones, you can go ahead and put them in there. Otherwise, we have a website here. It's a link. It's on their screen right now where you can ask any further questions to Tom. There's going to be a link that you can email him. Also at that link, you'll be able to download this presentation, and you'll also be able to watch a live recording of this webinar with audio, and the question and answer session will be at the end of it as well. Also, next month, our webinar series is continuing with Louis McCurley presenting a guide to compliance and safety in post-fall rescue for industry. Registration for that webinar is open. It's at the same link shown on your screen, and you can see more information about it and register. And also, if you'd like to follow us on Facebook and Twitter, we do frequent posts for news and updates about PMI and VRS. So if anyone has any other questions, feel free to email Tom, and we hope you enjoyed it. And Tom, thank you very much for doing this today.
Thanks, everyone, for participating. Very good questions.
And actually, we do have one last question that we'll do because we're not out of time yet. So do you see many fire departments with towers in their response area actually buying ropes specific for the tower, or do they just go with the 200 or 300-foot ropes currently in use and go with the multi-stage rescues?
I've seen, I hate to keep waffling on these, I've actually seen both. What I've found a lot of times is for tower owners that have very large towers with lots of antennas, they like the idea of having a rescue rope that's long enough to conduct a rescue on site at all times. So again, if you have a 1,400-foot tall tower in your response area and you really don't want to stuff a 1,400-foot rope into your rig and drive around with it all the time, taking up all that space, a lot of times you can convince tower owners to let you store that rope on their site. And sometimes if you're really lucky, you can actually convince them to purchase the rope and keep it in an airtight bag or seal or a box on that site in a location that you could access in the event of a rescue. So it never hurts to ask, and what I've found is most tower owners are more than happy to meet you halfway on something like that. So it saves your department the expense of having to purchase a 1,200-foot rope. Again, the multi-stage rescues, they add quite a bit of complication onto the system with having to pass knots frequently and all that. But you know, if you're at a tower that's 150 feet or less, if you got a 300-foot rope, 9 times out of 10, that's going to be more than you need. But it's more when you get into these monsters that are around 1,000 feet or 700 feet even, that, you know, tying ropes together becomes a pretty scary proposition.
And we do have actually one other question. 3/8-inch rope is rated at 6,000 pounds, meeting any 15-to-1 safety factor of a single-person load. Is that acceptable?
Well, it's more of a system number that we're looking for, I think, when it comes to a lot of that. Yeah, it's more of not meeting, you know, the strength, the safety factor for that one item, you know, the maximum strength. It's more about the system as a whole. And when you get into ropes with the thinner diameter, like a 3/8-inch rope, it may be 6,000 pounds, but more often than not, you're going to find that when you look at the system as a whole, there's something in that system that's going to be less than 6,000 pounds, and that's where you're going to get into a little bit of trouble trying to meet those safety factors, I believe.
Okay, well, that seems to be it. Again, if anyone has any other questions, you can feel free to email Tom. A link will be up for his email at that website shortly, and the download link and the link to watch the live presentation will be up within 24 hours. So thanks again, everybody, for joining us today, and we hope to see you next month with Louis' presentation.
Great.
Have a
Thanks,
good day,
everyone.
everyone.
Have a great day.